All right, let's start a new unit, and today we're going to discuss representations of three-dimensional figures. So here is the content standard, and math practices 1 and 5 is what you'll use in the assignment. Previously, you've identified parallel planes and intersecting planes in three-dimensional figures. Now you're going to draw isometric views of three-dimensional figures and investigate cross-sections of three-dimensional figures. Two new vocabulary words, isometric view and cross-section. In video games, three-dimensional figures are represented on a two-dimensional screen. You can use isometric dot paper to draw isometric views, or also known as corner views, of three-dimensional geometric solids on two-dimensional paper. In example 1, it asks us to use isometric dot paper to sketch a triangular prism 6 units high with bases that are right triangles with legs 6 units and 4 units long. So first of all, we're going to mark the corner of the solid and then draw segments 6 units down, 1, 2, 3, 4, 5, 6. 6 units to the left, 1, 2, 3, 4, 5, 6, and 4 units to the right, 1, 2, 3, 4. This is called isometric dot paper. Draw the triangle for the top of the solid. Okay, so we're going to enclose this to make a triangle. Then we're going to draw segments 6 units down from each vertex for the vertical edges, because it's 6 units high, so from each point we go down 6. Then we're going to connect the corresponding vertices, and we're going to use a dash line for the hidden edges. So this is the back of the figure, which you normally couldn't see, so we use a dash line to indicate that that's the back of the figure, and we shade in the top of the solid. Okay, check your progress. Which diagram shows a rectangular prism 2 units high, 5 units long, and 2 units wide? So pause the video and study the figures and then come back and check your answer. So it's 2 units high, 1, 2, 2 units wide, 1, 2, and 5 units long, 1, 2, 3, 4, 5. Notice that this is 3 units wide. This one is more than 5 units long, and this one is more than 2 units high. Now we're to use isometric dot paper and the orthographic drawing, which we have here, to sketch a solid. Notice that the dark segments indicate breaks in the surface. Looking at the top view, it indicates one row, and each is a different height, and one column in the front that's the same height as this one. The front view indicates that there are 4 columns, 1, 2, 3, 4, 4 standing columns. The first column to the left is 2 blocks high. The second column is 3 blocks high. The third column is 2 blocks high. And the fourth column to the right is 1 block high, and again, this dark segment indicates a break in the surface. The right view indicates that the right front column is only 1 block high, and again, the dark segments indicate a break in the surface. The left view indicates that the back column is 2 blocks high, so we draw the figure so that the lowest columns are in front, and connect the dots to the isometric dot paper to represent the edges of the solid. So which diagram is the correct corner view of the figure given the orthographic drawing? So using these pieces, it'll make which drawing? So pause the video and then come back and check your answer. Again, the answer is C. A cross-section is the intersection of a solid in a plane. The shape of the cross-section formed by the intersection of a plane and a three-dimensional figure depends on the angle of the plane. A customer ordered a 2-layer sheet cake, so notice we've got 2 rectangular pieces, 2 layers. Determine the shape of each cross section of the cake below. Well, if we do a cross section horizontally, then the cross section will be a rectangle. If the cake is cut vertically, the cross section will also be a rectangle, a much smaller rectangle. A solid cone is going to be sliced so that the resulting flat portion can be dipped in paint and used to make prints of different shapes. How should the cone be sliced to make prints in the shape of a triangle? So pause the video and study each of the answers and then come back and check your solution. Why, of course, the cone cut perpendicular to the base through the vertex of the cone will make a shape of a triangle. Very good. You're ready to begin working on the assignment.